Hello everyone, I am Harsh Khatta, working as Assistant Professor in Department of Computer Science and Engineering at ABS Engineering College, Ghaziabad. Welcome to the lecture series of Computer Networks. Today, we will discuss about the network devices and network topology. In last class, we have discussed about the OSI reference model and TCP IP model, and we have seen how these devices, how these layers are using the particular protocols and their functionality. Today, we will see how the network devices are mapped with these layers and what is the functionality of these network devices. When we talk about the network devices, our first thing is the NIC card. In our computers, laptops, there is a device which is used to connect to the network, that is known as network interface controller. I hope you have seen a figure like this which is mentioned here. In this, there is a LAN port where we can add the LAN cable for the net connection. Now, it is modernized and there is a Wi-Fi receiver and the controller for these type of things. So, this network interface component is basically used to connect to your system to the network. Okay. So, this is a very important device which is built in when we are talking about the computers and laptops. Next important one is basically the hub device. We all have seen these type of devices at our workplaces and colleges and other organizations. This is known as hub. As we say, yes, this is a hub of employees. It means all the employees who are there are of a same organization. In a same manner, when we are talking about connecting a particular network with the laptops, then we are using the hub. In hub, you can see here the similar type of ports are there, and these ports connect all the computers in a single network. So, as we have seen in the star topology, that we can see that how the data is traversing from one computer to another computer. Suppose my one computer is placed here and it is connected towards the hub, this port, and my second computer is attached here which is on this port. So, you can see here that in a single device multiple slots are available and I can connect multiple computers. If any of the packet is sending through this, say PC1, it will go to this particular device which is hub, and it will float it towards all the network devices, all the computers which are connected here like PC2, PC3, like this, and these data packets are traversing towards all the PCs. Now, we need to select, okay, the packet is for the PC2, not PC3. So, it will not move here, it will only go at this port. So, this is the functionality of hub. Now, there are again modernization in the hub and it is now collaborated with the modem. We will see this collaborations in the upcoming topics. Now, this is all about the hub. Next is a repeater. Now, this is an interesting device which is not placed at your home or the workplace. It is basically used to enhance the range, enhance the signal. Okay. If I am sending some data from this point to a particular computer which is 1 kilometer far away from my system. So, in this case, if there is a cable and I am sending the data through cable, and each and every cable has its own capability. Suppose I am talking about twisted pair. So, the range is approx 200 meters. After every 200 meters, there is a requirement of one device which restores the signal. Okay. Why we are talking about this thing? Say, I am giving one example. Suppose I am standing here and the next PC, this is a receiver 1, I am sender, and the distance is approx 1 kilometer, and the wire, the cable for sending the data, for transmission of data, I am using twisted pair. So, twisted pair is one category which we are using here. So, twisted pair uses the distance of 200 meters to preserve the signal. After 200 meters might be the signal starts distorting. So, in this case we need to restore the signal, original signal. Might be I am sending a hello world and this is converted to the signal, and after 200 meters it will distort and might be 1 or 2 bits will lose. Okay. So, in this case this is a diagram, this is a repeater which is required after every 200 meters. So, how many repeaters are required like this? So, in this case this is a distance. So, after 200 meters repeater 1 is there. Next again repeater 2, repeater 3, repeater 4. So, now the distance is 200, 200, 200, 200, 200 and finally you got your message at the receiver end. So, in this case 4 repeaters are required. This is the one case of twisted pair. Similarly, we have various types of cables where we are sending our data. Based on the cable capability and the characteristics, these lengths are defined. Okay. Now, as I gave an example of this data sending, here this repeater is one device which restores the signal, regenerates the signal. How it is possible to regenerate the signal? Because there is some signature in the data which we are sending. So, signal fetch that particular signature and restore the data. This is one example. You can see here that we have a weak inbound digital signal, and when it is passed to the repeater, then repeater will give the strong outbound digital signal. Now, repeaters are also modified, and we have seen there are so many devices which we can add at our workplace or home to extend the Wi-Fi range. Suppose I have placed a Wi-Fi modem at my home and the range is say 10 meters, and after 10 meters it won't work properly. So, in this case I can use a repeater, a Wi-Fi repeater is there, and this Wi-Fi repeater can extend the range, the signal will increase, the signal range will increase, and after say 10 meters I can also use the same signal. Okay. So, this is the example of how we can extend the range or how we can regenerate the signal. This is the example of repeater. Let us have a look to the another important device which we generally use at our home, which is known as modem. Now, what exactly modem is? Modem is a device which is used for the modulation and demodulation. Okay. And when we talk about the usage of modem, we have seen the broadband connections are there, and there is a wire, the optical fiber or this type of wire which is coming to our home, means might be we are talking about the wire which we are adding at this place, or previously there was a DSL connection by the company like BSNL or MTNL, and they provide us these type of services through the modem. So, the modem is a device which takes the input from at this point, and we can take the outputs through the LAN cable, as well as it also supports the wireless capability. So, here you can see, yes, modem is one which is used to spread the internet at a particular place when there is an input line which is coming. But here these 4 points are similar to the working of the hub. So, here in these type of modems the hub is integrated, but the difference is basically in these type of modems the ports are less in number, and when we are talking about the hub, so it can be of 8 port, 16 port, 32 port, just to attach all the systems through a network. So, these are the commonly used network devices which we use in our day to day life. The devices are not only these 4, there are high end devices as well which we can use in the network designing. Let us talk about this. We have bridges, switches, router and gateway. These are typically known as the network devices in computer networks. The thing which we have discussed about the hub and modem, the working of bridge switch are almost same, but the change is in the little bit functionality. Let us have a look about the bridge. Bridge is one thing which is used to connect the LANs. Suppose in your lab there is one particular hub where all the 20 or 30 pieces are attached, and if you want to send the data in a network, then you can send it easily. But there is one lab on the right side of your block, and there is another lab the left side of your block, then you want to connect these two labs. So, here we can generally use the bridge. Bridge is the extended version of hub. Okay. So, it is clearly mentioned here when we talk about the bridge properties. So, it is used to divide the larger network into the smaller ones. So, this is very important point to understand and the differentiate between the hub and bridge. So, hub is basically just to connect all the devices at the LAN level, and the bridge is basically used to divide the LAN into the sub networks. Here there is also one important point about the bridge, that at max we can add the 4 to 6 LANs in this. If we want to add some other networks in this, then we need to switch to the switch, this one. So, here this switch is basically similar to the hub as well as the bridge, but it is used on the larger scale. And one more advantage over the bridge is it helps in filtering the packet. Take an example, if 4 labs are there in your college and they are connected through a single switch. So, these are the lab 1, lab 2, lab 3 and lab 4, and this is your switch. Now, if somebody is sending a packet, somebody is sending a data or signal, then switch will receive that particular data, and switch has a power to decide that where to send the data. This is not the capability of hub. Okay. So, here it is a more extended version of hub and the bridge. So, it is up to our requirement what we need to use. If we want to use in a smaller network where the security is hardly matters, then we generally use hub. If we want to connect the two LANs, then we have bridge, and if we want to add the filtering function, the filtering of data, then it is better to use the switch. So, these are some important concepts to understand where and when to use which device. So, these till this, the devices which we have discussed are the basic devices which are used up to layer number 2. I will also discuss about the previous devices, that these devices belong to which particular layer and the category. The next, the upper one is basically known as the router. This router is another good device whose role is to route the packet. Take an example, that when we are surfing from the particular website, then the data is coming from us, but there are multiple hops in between, and you are receiving the data from which particular route. This is decided by the router. Take a layman's example. If you are going from Delhi to Ghaziabad, there are so many routes to reach. What we generally prefer, we can opt for the Google map, and in Google map there are so many routes which we can see, and in among all the routes there is one route which Google is suggesting us to go for the particular journey. Why? Because the congestion is less and the time is less. If we prefer the another route, might be there is a congestion or traffic on that route, or it will take more time. Okay. So, here this Google map is basically one entity which is helping us in finding the route. In the same manner, in networks, when we are talking about the sending a packet from one system to another, then there is a router who is working, and yes, this router is basically outside your network. If you are sending a packet inside your network, suppose in lab I am sitting and I want to send a packet from one system to another. So, I am not going to the upper layers, I am not reaching to the level where I can use the IP addressing and all, because routers check the IP address, and based on the IP address the hops are identified that where we need to send the data and what is the preferable route to follow. So, router is one device which is used to find the path and send the packet, and the successful transmission is on behalf of the route which is selected by the router. So, here this router is basically a layer 3 device which identifies or defines the path. If I talk about the gateways, gateway are the uppermost layer devices which we are using in a network. Generally, the gateways use at the network's boundaries. Okay. If I want to send a packet to a particular network and the network does not allow to receive the packets from intruder or some strange person. Suppose I am in ABS and ABS has created its own group, that harsh.khattar@abs.ac.in, and ABS has a constraint on the server. I do not want to receive the packets outside the ABS or only from the Gmail. So, all the emails which are receiving through the Gmail server, they are only allowed. If somebody is sending the from different domains, suppose @abc.com, so it won't allow this. So, here these type of filtrations we can apply on the gateways. Gateways are of two types. We will see in detail when we are talking about the routing and the broadly network security, that which type of gateways these are and which type of facilities they are providing. So, right now if I talk about the gateways, so gateways work on the network boundary and they have a capability to apply the filters as well as to change the protocol. Suppose a mail is coming from the POP and you want to convert it to the SMTP, then yes, this is possible. Okay. So, these type of protocol conversion or rule conversion are also possible in the gateway. So, yes, the functionality is much more about the gateways in a particular network. So, now we have discussed about the 8 devices. Let us have a look for the layers where these devices are applicable. Let us have a look to this figure. Here it is clearly mentioned, when we are talking about the hub and repeater, they are layer 1 device. Layer 1, just recall the thing, layer 1 means the physical layer. So, at physical layer we generally use the hub and repeaters. When we talk about the NIC card, as NIC card also contains a MAC address, the physical address of a computer node. That is why we can say yes, NIC is used at layer 1 and layer 2, because layer 2 is data link layer and it categorize it into the MAC layer. So, MAC is one address which is used here in the computers as a physical address. Modem is also categorized in both the layers, the layer 1 and layer 2. So, if we talk about the modem, so modem is layer 2 device. If we are placing any of the device and I am saying it is a layer 2 device, it means it works till layer 2 and it does not mean it does not support layer 1. So, if there is a router who is a layer 3 device, so it is by default using the first layer, second layer and then the third layer. Okay, so this is very important to understand. That is why in the figure you can see, if we are talking about the switch which is layer 2 device, bridge which is layer 2 device, it means the control is coming from the physical layer which is layer 1 and then layer 2 and then switch is placed here. But the scope of switch is not beyond layer 3. Okay. Yes, as I said, some of the modern switches are coming which are giving you the much more functionality. So, yes, this is integrated with the other devices as well. But when we talk about the traditional use of the switch, so it is up to the layer 2 only. Similarly, the router is layer 3 device and gateway is used at all 7 layers. So, we can also define the working of the gateway, which is from layer 4 to layer 7. It is up to us that which type of gateway we are using. As I said, that we have the variety of functionalities which we can add. In a similar manner, we can add the gateway type. So, this is all about the network devices and how these are attached with the OSI model layers. Once we discuss about the devices, the next thing is basically the communication among the devices. Yes, we have the nodes, we are aware about the network elements. In network elements, we need some nodes like sender, receiver, we need some message or data to send or signal, then the transmission medium is there and some set of rules. Now we are talking about that particular communication. So, this communication can be possible in three ways. One is the simplex. Simplex means if I am sending a data, then the another node is receiving the data, that is it. Means we are not supposed to send it to the multiple devices, or we are waiting for the response from those devices. So, this is a one way communication we can say, and this is the category which is known as simplex. So, this is a one way communication, and yes, this is a part of network. Take a basic example, if I have a keyboard and I am giving instructions to my computer. So, this is one way, computer is unable to give the instructions to keyboard. Okay. Similarly, the mouse. These are the basic things which we can categorize into the simplex communication mode. So, this is unidirectional, and this is the example to understand. So, you can treat here, yes, this is your monitor and CPU, and this is your monitor and CPU, and this is our keyboard and such device which is only giving the instructions, not more than this. If we have another category where yes, both directional data transfer is possible, but one at a time. Okay. So, this is another category which is known as half duplex. Half duplex says yes, both the systems or both the networking nodes can interact with each other, but one at a time. If node A is sending a data to B, then B will sit idle. Once the data transfer from A is done, only then B is able to send the data to A. So, this is known as half duplex communication mode. The best example is the walkie-talkie. We have seen these type of examples in the movies that yes, they are carrying the walkie-talkie and they are saying okay, over and out, yes, up to you now. So, this is the communication method, and yes, we have other devices, other examples where we are doing the communication in both the directions, and at the same time we can send and receive the data as well. So, mobile phones are the best example that we have seen. Yes, I am also talking and another person who is on the call is also talking. So, this is one example of duplex mode. So, duplex mode is a bidirectional, and at the same time both the things are possible. So, you can also relate these three categories with the help of arrow and their directions. So, yes, there is one direction and this is a single direction arrow. Here we are talking about the bidirectional, but one at a time. Here the bidirectional, and simultaneously they can do the things. So, these are some small concepts which are important to understand. Now, the network devices are done, the communication is done. Now, how a particular network is organized? So, we are talking about the network topology. Network topology means that physical organization of a particular network. In some of the content, there is mentioned that the topology is related to physical as well as logical. Yes, we can also accept this point that physically how they are organized and logically how they are working. So, we can also say these are the important things. Basically, there are so many types of topology, but here we are talking about some general categories like the star, ring, tree topology, bus, mesh and hybrid. So, hybrid will cover all the other examples. One by one, let us have a look to these topology. The very first example is star topology. Star topology is a basic example where we have a common hub with us. I am giving this example because recently we have discussed about the network device hub. You can treat here a hub is there and all the computers are connected through this hub. If any of a computer is sending a data, then first it will go to the hub and then hub will propagate it to other devices. There is a good thing about a particular topology that the data which is coming to the hub, suppose this is sender, so it will propagate it to the all computers, so anybody can respond. But there is a drawback. If there is a secure mechanism, means we are talking about a secure message, I want to share this which is confidential, then hub will propagate it to all. So, here it is not preferable to use the hub. Basically, these type of organizations, the topologies are up to the task which we want to perform. So, if we do not want some such secure medium and there is less number of devices to attach, then preferable one is star topology. I have not mentioned much theory in this because the topics are easy, and yes, you can easily write up the material here. You can also refer the reference which is mentioned here for more details. Another category is the ring topology. Ring topology is also preferable when we are talking about the nodes where we do not want the collision of packets. Suppose there are 5 nodes and A, B, C, D, all these nodes are sending their data to everybody. So, in this case there may be a congestion in the network. Okay. So, here to remove these type of conflicts, we are talking about the ring topology where there is a token and the node which is the owner of the token has rights to send the data. So, this is a good example where there is no conflict, but when we need to send the data very frequently, so it is not preferable to use the ring topology. In ring topology, if any of the network communication is broken, then you can't communicate with the next ones, because these ring topology generally supports a single direction movement. So, if A wants to send the data to C and the link is broken, in this case there is a issue and the network won't work. Okay. But in case of star topology, if one of the link is destroyed, then other can communicate. So, this is a good thing about star. As we know, each and every network has pros and cons. So, I am also discussing about these things. Another important diagram is about the bus topology. In bus topology, it is slightly similar to the star one with the same disadvantage that the packet is sending to the all nodes which are in between. So, suppose this is a sender node which is A wants to send a packet to this node E. So, in this case this A message will come to the common bus where he will send the message. As you are seeing here, the message is going to travel. So, first the message will go to this node, then this node, then this node, and finally to E. So, here there is no confidentiality of the particular message, and in any case if the link is broken at this point, so this message won't deliver to these two devices. So, this is also a drawback. What is a good thing? It is very easy to implement. In LANs we generally use this thing. So, yes, we have a common wire and we are connecting all the devices with this. So, if we do not have much secure information to send, so it is better to use the bus topology. Next one is the mesh. Mesh is generally used where we want to send the package to each and every node, and if we are talking about the node failure or a particular link failure. So, in this case the network is least disturbed because each and every node is connected with the each and another every node. Mesh topology is of two type, one is the partial and one is complete. So, this is the example of complete mesh where each and every node is connected to the another one. So, this type of example is complete mesh topology, and suppose I am removing this particular edge or this particular communication link. So, it will become a partial mesh topology. So, what is the advantage of this? If we are talking about any node failure or the link failure, in this case the another nodes or link won't affect, and the drawback, the cost is more. It is highly expensive when we are talking about the other topologies. Another two are the tree topology and hybrid. Tree is something which is a collection of the star and the bus which we have discussed, and hybrid is any other combination where we are adding 2 or 3 topologies together to make it the hybrid one. So, this is a very important to understand which type of topology we want as per our requirement. So, this is important concept to understand. Okay. So, if I talk about all the topologies, topologies are the network organizations. Now, take an example. I am saying I want one hybrid structure where I have created a particular node and this is attached with the another one, and now the LAN systems are connected like this. So, what it means? I am here talking about the bus architecture. So, this is bus topology, and here this is a star one because all these nodes are attached to this. So, this is a combination of star and bus, that is why we are talking about the tree. And if we are using here the other devices, which are connected like this. So, this is a mesh and above one is the star. So, this combination is basically the hybrid topology. So, hybrid topology says we are talking about multiple arrangements as per the requirement. So, I hope now you are able to understand what exactly the topology is, how the devices are organized in a particular network. This is basically my topological structure. So, now there is a question, how you can select a network topology. Basically, it is up to our requirement and how many devices which we are using. Suppose I want a particular network model where we have only 10 to 12 systems and we need to place it in the lab or in a cyber cafe type sort of thing. So, in this case we generally use the bus topology, where we are talking about the basic computers which are attached to each other for the practice purpose. But when we talk about a cyber cafe where we are giving the access to use the internet and somebody sending the mail and these type of things, then we need a special characteristics. So, in this case we have a different category. When we have a smaller network and we do not want to lose the packets, then the star topology is another one. So, here we can say yes, star topology is also good because we can easily scale up the network, so many systems we can add. Yes, based on the requirement, might be the hub, central hub is of 8 ports and we want to enhance the network to 12 ports. So, in this case the next hub need to be purchased of the 16 ports. So, these type of things are there when we need to scale the network, but it is easy to scale when we have the star topology. Fully meshed topology is basically a theoretical concept which is not possible practically. So, practically we use the partial mesh topology, and when we want to use the twisted pair type of thing, then again it is better to use the star topology because the range of the devices and the distance among them is less. So, in this case the twisted pair is the least expensive wire. So, that is why the star topology is preferable in this. So, if I sum up the lecture, that what we have learned from this. So, what is the role of network topology? These type of questions are very important for the university exam. Might be you will see the same questions in the university exam, that how we have the network topology, what is the role of network topology. So, this is very important thing. Another one is the layer wise devices. This is important. The difference between the hub, bridge, switch, router, this is again important. What are the major differences of the working style of mesh and star topology? What are the advantages and disadvantages of each type of topology? So, I have discussed with the figure and the example. You can just refer the book link Forozon or Tannenbaum for the detail purpose. Now, a open ended question for you. If you are making your own network, which type of topology you will prefer? Yes, I answer this question. It is up to your network requirement, but you can think which type of network you want and what type of topology you can use. So, this is all about the today's lecture. In the next class, we will talk about the delay in the networks. Thank you.